Hello everyone. So we are going to start the part 9 from the unit course dispersion. So even in this unit we are going to discuss again the mechanism of action of different emulsifier, right? And the theory of emulsification. So without wasting any time, let's start the topic. So you see emulsifying agents, that is, here we are going to discuss the theories of emulsification. So as per the theories of emulsification, basically the emulsifier or emulsifying agent, they generally form three types of layer. One, it is known as the monomolecular layer, another one it is known as the multimolecular layer, and sometimes it is also known as the branch molecular layer, and one it is the adsorb one. So let's start. So you see the surfactant molecule, actually the surfactant, they generally forms the monomolecular absorption at the surface of the globule, that is their dispersed phase. Now this surfactant, actually they try to reduce the interfacial tension. Thus the oil droplets, they generally surrounded by a coherent monolayer of the surfactant, and this monolayer of the surfactant actually prevents the coalescence. So if the emulsifier is ionized, suppose we have used an ionized emulsifier, then the presence of strong charge may lead to repulsion in the droplet, hence it increases the stability. I repeat, if the emulsifier is ionized. Now what is the ionized emulsifier? You see, we are using the surfactant. So in surfactant we have cationic, anionic and non-ionic type of surfactant, right? If we are going to use the cationic or anionic type of surfactant, then definitely the dispersed phase, that is the oil globule, will possess some definite charge over this layer, right? And this will ultimately lead to repulsion, and thus it increases the stability of the suspension, of the emulsion. The next one, it is the hydrophilic colloid. They form the multimolecular adsorption, and lastly that is the finely divided solid particles. So these solid particles, they also get adsorbed at the surface of the oil droplets. So they actually adsorb at the interface between the two immiscible liquid phases to form a particulate film. This particulate film, it is the film which is made up of the particles that are the finely divided solid particles. Clear? Now how does emulsifier agent work? That is the mechanism of action. You see here, this is a surface active agent, that is a surfactant. They generally form monomolecular layer. So you see just a single layer of surfactant you will find here. So in this, you know that these are, suppose we have considered this for oil in water type of emulsion. So this is the oil droplet, right? So the molecule of the surfactant, in the molecule of the surfactant, the tail, this is the hydrocarbon tail, it will come towards the oil phase, whereas the polar head, it will remain towards the water phase, right? They will form a monomolecular film. Now this is the hydrophilic colloids, they will form what? Multimolecular film. But here no extrusion, or you can say no protrusion of the layer or of the molecule of the surfactant takes place. And this is the general one, this is the solid film particles. So let's discuss again. Monomolecular adsorption, as we have already stated, this is the amphiphiles. Amphiphiles are also known as the surfactant. They reduce the interfacial tension up to 1/9 per centimeter because of the adsorption at the interface of the oil and water. So the droplets, now the droplet means the droplets of the oil are now surrounded by a coherent monolayer that help prevent the coalescence, that is the merging of the two droplets. And the surface charge, if the surfactant have any charge, then this surface charge, it causes the repulsion between the globules. So the combination of the surfactant is generally used as it is more effective. So generally we use the combination of surfactant. For example, combination of sodium cetyl sulfate and cholesterol, it leads to the complex film that produce excellent emulsion. So this type of combination you can use in the preparation of actually liposome also. The next one, hydrophilic twin. It's a surfactant. Hydrophilic twin can be combined with the lipophilic span. Span is also a surfactant. in varying proportion to produce the desired either your water in oil type of emulsion or oil in water type of emulsion. Clear? Now surfactant and co-surfactant, let's study. So this is a oil droplet. Suppose this is a oil droplet. So this is the hydrophobic phase. We know that the oil is a hydrophobic in nature, and this is the water surrounding it, that is a dispersion medium. So this is an oil in water type of emulsion. This is the hydrophilic phase. So here you see the red color one, these are the surfactant molecule. So and this blue color one, these are the co-surfactant molecules. So the surfactant molecule actually they forms the interfacial film over the oil droplets, and the co-surfactant they actually ensure the flexibility of the interfacial layer. They generally helps to increase the flexibility. They reduce the interfacial tension. This co-surfactant they reduce the interfacial tension. This co-surfactant are the surfactant which are used along with the surfactant. Clear? Now the monomolecular adsorption, let us discuss the Hlb concept, the hydrophilic lipophilic balance concept. So you see the type of emulsion produced, it depends upon the property of the emulsifying agent. I repeat, the type of emulsion you want to make, it depends upon the emulsifier you are using, because some of the emulsifier will help in the formation of oil in water type of emulsion, and few emulsifier will help in the formation of water in oil type of emulsion, right? So the type of emulsion is a function of relatively solubility of the surfactant. The type of emulsion is a function of relative solubility of the surfactant. So there is a rule. This rule, it is known as the Bancroft rule. So what the Bancroft rule say, the phase oil and water in which the surfactant is relatively more soluble will become the continuous phase. Suppose we have used a surfactant, suppose the surfactant is more soluble in the oil phase, then the emulsion will become water in oil. If the surfactant is more soluble in the water phase, then it will become oil in water. As per the Bancroft rule, the phase in which surfactant is relatively more soluble will become the continuous phase. Suppose if the surfactant is more soluble in water, then the continuous phase will be the water. If the surfactant is more soluble in the oil, the continuous phase or the dispersion medium will become the oil. Done. So high Hlb surfactant prefer formation of oil in water emulsion and vice versa. High Hlb means high hydrophilic lipophilic balance surfactant value means emulsifier. High Hlb surfactant will prefer the formation of oil in water type of emulsion, and low Hlb surfactant will prefer the formation of water in oil type of emulsion. Clear? So you see, a system was developed to assist in making the systematic decision about the amount and the types of surfactant needed in a stable product. So this is the value actually I have given here. So this scale, this is Hlb, this is the hydrophile lipophile balance or hydrophilic lipophilic balance, whatever you used to say, you can say. So the Hlb, this is the hydrophile lipophile balance. This start from 1 up to 18, right? So the Hlb number actually they are experimentally determined for defined emulsifier, and this emulsifier they act as a surfactant. So you see Hlb value 1 to 3, this can be added as a anti-foaming agent. Hlb value 3 to 6, you see lower the Hlb value, it will prefer the oil in water type of emulsification, water in oil type of emulsification. Higher the value, it will do oil in water type of emulsion. Clear? Now the surfactant example, anionic surfactant, right? This anionic, so anionic surfactant, so these anionic surfactant are nothing but these are the organic salt, right? They have surface active anion. Example, alkali, metal and ammonium soaps we have. These are the salts of the long chain fatty acids such as your sodium stearate, potassium oleate. Soaps of divalent and trivalent metals such as calcium oleate. Then amine and ammonium soaps, example triethanolamine. Even you can have alkyl sulfate such as sodium lauryl sulfate. But there are some disadvantages of anionic surfactant. Number one, they are irritant internally, so widely used in the external preparation as oil in water emulsifying agent. and anionic surfactants are generally stable at the more alkaline pH. So these are their disadvantages, right? The next one, it is the cationic surfactant. So they are usually the quaternary ammonium compound which have surface active means action. Example, cetrimide, benzalkonium chloride, right? They are used in the preparation of oil in water type of emulsion for external use, and they must be in their ionized form to be effective. You should remember the cationic surfactant, they must be always in the ionic form. So the cationic surfactant, they also have antimicrobial activity also, because you know that benzalkonium chloride, it is used as a preservative or due to its antimicrobial activity, it is used as a preservative. Disadvantage, they are sensitive to ionic surfactant and drugs. Cationic surfactants, they are sensitive to ionic surfactant as well as drug. Emulsion formed by the cationic surfactants are generally stable at the acidic pH. So if you are willing to make a emulsion and you are using a cationic surfactant, then the pH of the emulsion should be in the acidic range, and they are more toxic than other type of the surfactant. The next one, it is the multimolecular adsorption. Here you see the molecule, they don't protrude inside the oil droplets, rather they will form multi-layer above the oil droplets, right? So the hydrophilic colloids, example is your gum acacia. Mucilage of gum acacia of different in action from that of the surfactant, right? So they do not cause the mucilage, they don't cause the lowering of the interfacial tension, rather what they do, you see, they form multi-layer at the oil water interface, and the action of the hydrocolloid because of this reason only, because they form multi-layer at the oil water interface. So they actually increases the viscosity of the dispersion medium. The hydrocolloids, they form multimolecular adsorption, right? And hydrocolloids, they mainly work by increasing the viscosity of the dispersion medium, right? The hydrocolloid example, we have natural polysaccharide. For example, we have acacia, right? You see, the main problem with this actually natural polysaccharide is that their natural variability between batches to batches, because in natural products we don't have a standard one actually, right? Moreover, chances of microbial contamination is very high in case of the hydrocolloids, right? This material should be used externally as they leave a sticky feel on the skin, right? So this should not be used. I'm sorry, this hydrocolloid, they should not be used externally, because the hydrocolloids, they are actually gum-like, they have gum-like properties. So if we use hydrocolloids externally, what will happen? You will feel stickiness over your skin. Acacia, it is the best emulsifying agents prepared in the oral emulsion, right? So next example, it is your tragagant. It is used to increase the viscosity of the emulsion and prevent the creaming. Other polysaccharide example, starch, pectin, carrageenan, they are also used to stabilize the emulsions. So all these hydrocolloids, they act by forming multimolecular layer over the dispersed phase, right? Even you have the semi-synthetic polysaccharide. These are derived from the natural one, from the cellulose actually. You see, methyl cellulose, carboxy methyl cellulose, hydroxypropyl methyl cellulose, right? Even you have synthetic hydrocolloids like carbopol, polyphenyl alcohol, polyphenyl pyrrolidone. Now the next one, it is your solid particles adsorption. They will just form a layer, particle layer over the dispersed phase. So the solid particles, they can be wetted by oil as well as the water. We know that, right? So they can act as an emulsifying agent, right? So their concentration, the concentration of this solid particle is higher, always higher at the interface between the oil and water. So they generally forms, the solid particles, they generally form a particulate film over the dispersed droplet to prevent the coalescence of the dispersed phase. So example of the solid particles which you can use, bentonite and vigam. Vigam is the magnesium aluminum silicate. Vigam, it is a trade name. You should know vigam is magnesium aluminum silicate. So emulsifying agent, again I repeat, so these agents, they form a particulate layer over the dispersed phases, right? So these agents, actually these particulate agents, they swell in the dispersion medium to increase the viscosity, right? And it reduces the interaction between the dispersed droplet. So most commonly this finely divided solid particles, they are used to support the formation of oil in water type of emulsion, right? Example again, bentonite, weak gum, hectorite, magnesium hydroxide, aluminum hydroxide, magnesium trisilicate, and all. So I have given this extra information to you so that it will be helpful for you regarding your examination. So thank you everyone. If you like the video, just press the like icon. You can share this video and you can subscribe to my channel. Thank you once again.